For 160 years, Earth's magnetic North Pole moved less than 1 kilometre a year. Then, in 1994, it broke into a run. By 2010, it was crossing the Arctic Ocean at 58 kilometres a year, the fastest it has ever been recorded to move. And then it hit the brakes harder than it has ever been observed to brake, and nobody can tell you why. All of that is happening while the surface of this planet puts on its most conspicuous display in years. 53 eruptive episodes at Kīlauea, the strongest earthquake in 40 years under Naples, a hurricane over the Big Island for the first time in a century and a half. Millions of people looked at that list and decided it was all connected. They are almost right. And the part they have wrong is the most interesting part of the story. If you want this explained honestly, rather than sold to you, hit that like button and subscribe. And drop a comment telling me where you are watching from and whether you have ever caught a compass, or a phone heading pointing somewhere it should not. Now, let's get into it. Part 1. The 3 weeks that made everyone look up. On the 12th of August, 2026, at 3:45 in the afternoon Hawaii time, the floor of Halemaumau crater opened up and threw a column of molten rock 500 feet into the air. It was the 53rd time that had happened in about 1 year and 8 months. On the same date, on the other side of the planet, the moon's shadow swept across the Arctic Ocean, reached its maximum over Iceland, and raced down through Spain. 2 days after that, a rock about 16 inches across came apart in the sky over Washington state, with the force of 10 tons of dynamite, and rattled windows across 2 countries. On the same weekend, a magnitude 7.7 earthquake killed at least 47 people in Indonesia, and a hurricane, the first to make landfall in the state of Hawaii since 1992, drove its eye wall across the southern tip of the Big Island while that volcano was still glowing. If you spent the middle of this month feeling like the planet was doing something, you were not imagining it. Every single one of those events is real, verified and documented by an agency you can look up yourself, and millions of people looked at that list and arrived at the same conclusion at roughly the same time, which is that these things must be connected, because it is almost impossible for a human brain to look at that many extraordinary events in that small a window and file them as unrelated. So let me tell you the honest answer up front, because I am not going to make you wait 2 hours for it. There is a pattern. It is not the pattern most people think it is, and underneath all of it, there is one system on this planet that really is doing something strange, something measured, something documented in numbers that have never been seen before in the entire history of the instrument, and almost nobody is talking about the part of it that matters. That system is Earth's magnetic field, and the thing it is doing is not what you've been told. Here is the number that started me down this road. The North Magnetic Pole, the place where this planet's magnetic field lines plunge straight down into the ground, has been moving for as long as anyone has measured it. For a century and a half it crawled. Then, in the middle of the 1990s, it broke into a run and covered more than 50 kilometres a year, which is a pace nobody had ever recorded. And then, around 2010, after reaching the fastest migration in the history of the measurement, it hit the brakes. It slowed down harder than it has ever been observed to slow down. That deceleration is the single largest slowdown in pole speed ever measured, and no one can tell you why it happened. That is the story. Not a coming apocalypse. Something better. A planet whose deepest, least accessible system is visibly changing its behaviour in ways that the people who study it professionally cannot yet explain, while the surface of that same planet puts on the most conspicuous display it has managed in years. But I want to be very careful here, because there is a way of telling this story that is dishonest, and I have seen it told that way a lot in the past 2 weeks. The dishonest version says the earthquakes and the volcanoes and the storms are being caused by the magnetic field. That claim does not survive contact with the evidence, and I am going to walk you through exactly why, including the piece of scientific literature that gets cited for it, and what that literature actually says, which turns out to be almost the exact opposite of what people think it says. The honest version is subtler and I think more unsettling. It says that Earth in 2026 is operating inside a particular set of physical conditions, and those conditions raise the odds of visible events without causing any specific one of them. That is a real thing. It has a name in the sciences that use it, and it is the difference between a loaded die and a rigged game. So we are going to do this properly. We are going to start with the cluster, because that is what got your attention, and because there is one case inside it where the connection people are imagining is not imaginary at all. It happened, it is documented, and the scientists who study those specific volcanoes said so on the record. That case is going to become our measuring stick. Anything else that claims to be a connection has to look at least as good as that one. Then we're going to leave the surface entirely and go down to where the magnetic field is actually made, 3,000 kilometres beneath your feet, into liquid iron moving in the dark, and that is where the story turns, because the reason the pole started running in 1994 is not the reason you have probably heard. Let me set the scene properly on the cluster, because the details matter more than the headlines. Start with Hawaii, because Hawaii is where two of these events collided in the same week. Kīlauea has been erupting from its summit in discrete bursts since December of 2024, not a continuous flow. Episodes. The volcano fills, pressurizes, and then throws a fountain of lava out of a vent for a matter of hours, and then it stops, and then it does it again. Episode 53 started at 3:45 in the afternoon on the 12th of August, and ended abruptly at 1:23 the following morning, after 9.6 hours of continuous fountaining. The fountain from the north vent reached about 500 feet, or 150 meters. The gas plume above it climbed to 18,000 feet above sea level, which puts it in the flight levels. The numbers underneath that are worth sitting with. At the peak, around 5:15 in the evening, the instantaneous rate at which lava was leaving the ground was about 300 cubic yards per second. Averaged across the whole episode, it was around 180 cubic yards per second. By the time it stopped, roughly 6 million cubic yards of new rock had covered somewhere between 40 and 50% of the crater floor. And during that episode, a collapse pit above the south vent did something that required the Hawaiian Volcano Observatory to change its paperwork. It started behaving like a vent, so they classified it as one. There is now a west vent at Kīlauea that did not formally exist before the 12th of August. 53 of these episodes in about 20 months is a record. Not a record for lava volume, and not a record for danger. A record for the count of these fountaining episodes and the rate at which they have arrived. Something about the plumbing under that summit is cycling faster than it has been observed to cycle. Now hold that image, because 3 days later a hurricane arrived. Lala was a potential tropical cyclone with 40-mile-per-hour winds on the 12th of August. By the 15th, it was a Category 1 hurricane, and its eye wall brushed the southern tip of the island of Hawaii. That made it the first hurricane to make landfall in the state since Iniki in 1992, and reporting on the event placed the Big Island's own last direct hurricane landfall roughly 155 years ago. Rain fell at 3 to 5 inches an hour in places. More than 100 homes on the southern part of the island were damaged or destroyed. Flash flooding swept structures away. At least one person died. And here is the detail that explains why this felt so wrong to people who live there. The Big Island is not a low island. Mauna Loa and Mauna Kea both rise above 13,000 feet. A cyclone is a spinning column of air, and when that column runs into 13,000 feet of rock, the column gets disrupted. Historically, storms approaching the Big Island tend to weaken, deflect, or come apart. The mountain is the island's defense. Lalawent had it anyway. So on the same island, in the same week, the largest hotspot volcano on the planet set a record for eruptive tempo, and the first hurricane in a century and a half came ashore over the top of it. If you want to understand why so many people started looking for a common cause this month, that single sentence is most of the reason. And I want to be clear that noticing it is not a failure of reasoning. Noticing it is correct. What matters is what you do next. Because there is a version of what comes next that is rigorous, and it starts with a question. Has anything in this cluster ever been shown to cause anything else in this cluster? Not felt like it, not correlated with it, shown. The answer is yes, once, and it is not any of the events I have described so far. Part 2, the one case where it actually worked. On the 29th of July 2025, at 23:24 Universal Time, the seafloor off the coast of the Kamchatka Peninsula ruptured in a magnitude 8.8 earthquake. That is the largest earthquake anywhere on this planet since the magnitude 9.1 that struck Tohoku, Japan in 2011, and it sits inside the 10 largest recorded anywhere since 1900. Tsunami warnings and watches went out across the entire Pacific Basin. The rupture did not arrive without warning, which is unusual and important. For 10 days beforehand, that stretch of subduction zone produced roughly 50 earthquakes of magnitude 5 or greater, including a magnitude 7.4 on the 20th of July and 3 separate magnitude 6.6 events. In hindsight, that is one of the more productive foreshock sequences on record before a great earthquake, and it is the kind of thing that looks obvious afterward and is nearly impossible to act on at the time, because most swarms of that kind are not followed by anything. Then the earthquake happened, and then, within days, Kamchatka's volcanoes started going off. Krasheninnikov erupted. That volcano had not erupted in approximately 600 years. It sent an ash plume up to roughly 6,000 meters. Kīlauea, which is the most active volcano on the peninsula and one of the most active in the world, began erupting as well, with satellite data showing ash rising to about 9.5 kilometers above sea level, and the Kamchatkan Volcanic Eruption Response Team warning that explosions to 10 kilometers could occur at any moment. Siberia became intensely active and has stayed that way, building a new lava dome at its summit and firing off ash columns on a near-daily basis, columns that repeatedly reach the stratosphere. And here is the part that makes this case the measuring stick for everything else in this video. Russian scientists said publicly that the earthquake may have triggered Krasheninnikov's first eruption in 6 centuries. Not an anonymous claim online, not a pattern somebody noticed on a map. Researchers who study those specific volcanoes, looking at their own data, stating on the record that a causal link was plausible. Why does that claim hold up when so many others do not? 4 reasons, and I want you to remember all 4, because we are going to apply them to every other connection in this video, including the magnetic one. The interval was short. Days, not months, not years. When you are arguing that event A triggered event B, the time between them is the first thing that has to be defensible, because as the gap widens, the number of alternative explanations grows without limit. The distance was short. These volcanoes sit above the same subduction system that ruptured. We're talking about a few hundred kilometers on the same tectonic structure, not 2 points on opposite sides of a planet. The systems were already primed. Kīlauea erupts constantly. Siberia is one of the most restless volcanoes on Earth. Even Krasheninnikov, dormant for 6 centuries, sits inside one of the most magmatically productive regions on the planet. A magnitude 8.8 earthquake does not create magma. What it can do is change the stress on a system that already has magma sitting under pressure, and that is a much smaller and much more plausible request. And there is a mechanism. A great earthquake sends enormous seismic waves through the crust. Those waves change the stress field. They can unclamp a fault. They can shake gas bubbles out of solution in a magma body. They can rattle a crystallized plug loose. None of that is exotic physics. It is the same reason a shaken bottle of soda behaves differently from a still one. 4 conditions, all satisfied, and researchers willing to attach their names to it. That is what a real trigger case looks like. Now hold that standard in your head, because I want to walk you through the rest of the cluster against it, and you are going to notice something. Most of these events fail on at least 2 of those 4 conditions, and the ones that fail hardest are exactly the ones that have been circulating most widely. Take the deep earthquake near Toba. On the same weekend as the Indonesian disaster, a magnitude 6.9 struck Western Sumatra at a depth of 172.5 kilometers. Because it was that deep, it produced no casualties and no meaningful damage. People felt it as light to moderate shaking, and it drew an enormous amount of attention anyway, entirely because of where it sat on the map, which is near the Lake Toba caldera, the site of one of the largest volcanic eruptions in the history of our species. I understand the reasoning. A caldera that size has plumbing that extends far deeper than the shallow crust, so an earthquake at 172 kilometers is not obviously in a different world from that plumbing. It is not an absurd thought, but hold it up against the Kamchatka standard. There is no reported unrest at Toba. No monitoring agency has raised an alert level. No swarm has been announced. No deformation signal has been flagged. The interval is fine, the distance is arguable, the priming is unknown, and the mechanism is unstated. That is 1 condition out of 4, maybe 2 if you are generous. And there is a second problem with the Toba story, which is the story itself. We will come back to that, because it is one of the clearest examples in this entire video of a frightening fact that turned out not to be a fact. Then there is Italy, where two of the great volcanic systems of Europe did something notable within 2 days of each other, and where the connection people are drawing is not to an earthquake at all. It is to the magnetic field, which is where this video is going. But before we go down into the core, I owe you the rest of the surface. Part 3. What the rest of the cluster actually is. Mount Etna started erupting in earnest around the 29th or 30th of July, and more than 2 weeks later it had not stopped. Strong Strombolian activity continued at the Voragine crater into early August. On the 7th of August, Italy's National Institute of Geophysics and Volcanology reported ashfall at Regalna and Adrano, lava flows in the Valle del Leone, and a new eruptive vent opening in the Valle del Bove, with incoming flights suspended at Catania Airport. On the 10th of August, the ash and the lava were still coming, and Catania suspended arrivals again. Then, on the 15th of August at 24 minutes past noon local time, a magnitude 3.9 earthquake struck at a depth of 1.2 kilometres beneath Etna's northeast rift zone, with its epicenter 2.8 kilometres north of Piano Pernicana. A magnitude 3.9 is a small earthquake. Almost anywhere else on Earth it would not make the news. 1.2 kilometres beneath the flank of an actively erupting volcano, on a rift zone, buckling the surface of the access road above it, is not a seismic event so much as a structural one. Something moved inside the mountain and the mountain reported it. One day after Etna began its phase, the other Italian system produced the largest earthquake ever instrumentally recorded there. At 46 minutes and 43 seconds past 7 in the evening, local time on the 31st of July, a magnitude 4.7 struck Campi Flegrei, epicentered near the Solfatara crater at Pozzuoli at a depth of about 3 kilometres. 21 people were injured. The Cumana and Circumflegrea rail lines were suspended. The port of Pozzuoli was closed. At least 10 aftershocks followed, the largest a magnitude 3.8 at 10, in the evening out in the Gulf of Pozzuoli. 4.7 does not sound like much until you know the context. It is the strongest shock in that caldera in 40 years, and it exceeds the previous instrumental maximum, which was a pair of magnitude 4.6 events in 2025. Campi Flegrei is in an accelerating phase of something called bradyseism, which is the slow rise and fall of the ground as magmatic fluids and gases move beneath it. Since the current unrest began around 2005, the ground near Pozzuoli has risen by more than 140 centimetres. That is not a subtle number. That is close to 5 feet of vertical ground motion under a densely populated part of Italy, and the seismicity, the gas emissions and the uplift have all been climbing since 2005 and climbing steeply since 2020. So both Italian systems really are doing something, and this is precisely where the magnetic claim enters, because there is a body of scientific work connecting Italian volcanoes to Earth's magnetic field, and it is real work in real journals, and the way it gets described online is almost exactly backwards. I am going to spend a substantial part of this video on that, because it is the single best example I have ever found of a claim that sounds authoritative, cites genuine research, and has the arrow pointing the wrong way. Indonesia is the last piece of the surface story and the deadliest. At 5:58 in the morning local time on the 14th of August, a magnitude 7.7 earthquake struck at a depth of 10 kilometres, with its epicenter about 68 kilometres north-northwest of the city of Ende in East Nusa Tenggara province. It killed at least 47 people. Buildings collapsed. A tsunami warning went out. The aftershock sequence included events at magnitude 6.1, 5.9, 5.6 and 5.5. And around that, in the space of a couple of months, there is a genuinely grim list. A magnitude 7.8 struck the Philippines in June. A magnitude 7.2 and a magnitude 7.5 struck Venezuela as a doublet later the same month, with a casualty count that ran into the thousands of dead, missing and injured. A magnitude 7.1 hit southern Japan and did real structural damage. A magnitude 7.4 hit Colombia on the 10th of August. A magnitude 7.3 hit Mexico, and Fuego in Guatemala put on a spectacular display afterward. Now, is that abnormal? This is where I have to be very disciplined with you, because the honest answer has two halves, and most coverage only gives you one. In an average year, this planet produces roughly 15 earthquakes of magnitude 7 or greater. 5 or 6 of them inside a 2-month window is above the average. It is not far above what you would expect from ordinary statistical variance in a process that is essentially random in its timing. If you plot cumulative global seismic energy release in 2-week bins across the past 6 years, 2024 stands out as a notably weak year, and 2025 into 2026 stands out as sustained at high levels rather than spiking once and going quiet. So compared to 2024, this feels like an explosion of activity, and that feeling is data-driven. But if you average across 5-year windows going back to 2005 and earlier, the distribution flattens out considerably. The present period stops looking like an anomaly and starts looking like a busy stretch inside a normal range. Both of those statements are true at the same time, and telling you only the first one is exactly how honest data becomes misleading. There is also a scaling issue that almost nobody explains. The magnitude scale is logarithmic, and in terms of energy released, it climbs by roughly a factor of 32 for every whole step, which means the magnitude 8.8 off Kamchatka released on the order of 1,000 times the energy of that magnitude 6.9 near Toba. A single great earthquake dominates any cumulative energy plot it appears in, and that is why one event can make an entire year look unprecedented on a graph. So what is genuinely unusual about 2026 is not the count. It is the human cost and the geographic spread. Philippines, Venezuela, Japan, Colombia, Mexico, Indonesia. That is a function of where the ruptures happened relative to where people live, and it is a real thing worth grieving, but it is not evidence of a global driver. And then there is the absence, which nobody wants to mention because it ruins the pattern. Yellowstone is quiet. There is no elevated alert level. There is no unusual swarm. There is no deformation signal being flagged by anybody. In any honest accounting of a supposed global volcanic activation, the largest and most famous volcanic system in North America sitting the whole thing out is data. It is evidence about the pattern, and it points the wrong way for the doom version. I am telling you that because if I only told you the parts that fit, you would have no reason to believe me later when I tell you about the parts that genuinely do not have an explanation. 2 other items belong on the list, and then we can go underground. On the 14th of August, a bolide crossed the sky over British Columbia and Washington state, bright enough that hundreds of people filed reports and loud enough that seismographs installed to listen for volcanoes picked up its shockwave. We covered that event in detail in our video from August 15th, and I will not repeat the work here beyond the one thing it contributes to this story. It is the cleanest example in the entire cluster of an event that has nothing whatsoever to do with the others. A piece of asteroid arrived on a schedule set millions of years ago. It is a genuinely unrelated event, and knowing what an unrelated event looks like is how you calibrate everything else. And on the 12th of August, the moon's shadow crossed the Arctic Ocean, reached maximum over Iceland, and swept through Spain, which we covered on the eve of totality. That path has been folded into the pattern by a lot of people this month, because of where it went. And where it went turns out to matter for this video, in a way I did not expect when I started, because it crossed a piece of Arctic seafloor that is about to become the most important place in this story. But not for the reason anybody online is saying. The eclipse did not do anything to it. Something else is arriving there. Something that started moving in 1831, when a British naval officer stood in the Canadian Arctic holding a needle, watched it tip straight down toward the ground, and marked the spot. Part 4. A Man with a Needle on the Boothia Peninsula. James Clark Ross was 29 years old and stuck. His expedition's ship had been frozen into the ice of the Canadian Arctic for a second winter, which in the 1830s was the kind of situation that killed people routinely. So he did what a certain kind of 19th century officer did when trapped. He went for a walk, across the ice, on foot, dragging instruments, looking for something nobody had ever found. What he was looking for was a place to find not by geography but by behaviour. Take a compass needle and mount it so it can swing vertically rather than horizontally. That is called a dip needle, and everywhere on Earth it tilts. Near the equator it lies close to flat. As you travel north it tips further and further down, following the invisible lines of Earth's magnetic field into the ground. Somewhere in the far north there has to be a place where it points straight down, at 90 degrees, because that is where the field lines themselves go vertical and plunge into the planet. On the 1st of June, 1831, on the Boothia Peninsula, Ross found it. His needle went vertical. He had located the North Magnetic Pole, and in doing so he created something that turned out to be far more valuable than a dot on a map. He created a baseline. Because now, forever afterward, anyone who repeated his measurement could tell you whether the pole had moved. It had. And the record of that movement is one of the strangest and most underappreciated datasets in the earth sciences, so I want to walk it with you carefully, decade by decade, because the shape of it is the whole story of this video. Before we do, one thing needs to be clear about what this pole actually is, because almost everything else depends on it. The North Magnetic Pole is not a physical object. There is no iron mountain up there. It is not the geographic North Pole, which is simply the point where the planet's rotational axis meets the surface and does not move, and it is not the same thing as the magnetic axis of the field as a whole. It is a surface expression, a place where a particular condition happens to be satisfied, and the reason it is satisfied there rather than somewhere else has nothing to do with the Arctic at all. It has to do with what is happening about 3,000 kilometres straight down. Beneath the rocky mantle there is an outer core of liquid iron and nickel, hotter than the surface of the sun, under crushing pressure and in constant motion. That motion is convection driven by heat escaping from the inner core, twisted by the planet's rotation, and it drags magnetic field lines around with it, because moving metal and magnetic fields are inseparable. The whole arrangement is a self-sustaining dynamo, and it has been running for billions of years. The magnetic field we live inside is the output of that machine, and the position of the North Magnetic Pole is a readout on its dashboard, which means when the pole moves, something in the machine has changed. That is the only thing it can mean. And this is the thread I want you to hold on to through everything that follows, because it is the spine of the entire story. The pole's movement is not weather, and it is not a surface phenomenon, and it is not something being done to Earth from outside. It is the deep interior of this planet telling us, in the only language it has, that it is not doing what it was doing before. It is worth walking the machine step by step, because the steps are what make the rest of this comprehensible. Start at the centre. The inner core is solid iron, about 1,220 kilometres in radius, and it is slowly growing as the liquid outer core freezes onto it from the inside out. That freezing releases heat, and it also releases lighter elements that get squeezed out of the iron as it crystallizes. Those lighter elements are buoyant, so they rise. That is step one, a source of upward motion, powered by the planet slowly solidifying from the middle. Step two is that the rising fluid is electrically conductive because it is molten metal. When a conductor moves through a magnetic field, it generates electrical current. When current flows, it generates a magnetic field of its own. So a field that already exists gets amplified by the motion of the metal moving through it, and the amplified field then acts on the metal more strongly. That feedback loop is what makes a dynamo self-sustaining rather than something that needs winding up. Step 3 is rotation. Earth spins, and that spin organizes the convection into columns aligned roughly with the rotational axis, rather than letting it churn randomly. That organization is the reason the resulting field looks roughly like a bar magnet aligned with the spin axis instead of looking like noise. It is also the reason the field is not perfectly aligned, because the organization is imperfect and the columns wander. And step 4 is the part that matters for us. Because the columns wander, the field they produce is patchy rather than uniform. There are places where flux is concentrated and places where it is thin, and those patches drift and change strength on timescales of decades to centuries. Which means the surface expression of the field, including the position of the pole, is not a fixed property of the planet. It is a weather report on the core. That has a practical consequence that has been shaping human history since long before anyone knew about dynamos. The angle between where your compass points and where true north actually is has a name: magnetic declination. It varies with location, it varies with time, and if you do not correct for it, you end up somewhere other than where you intended. Every nautical chart, every aviation approach plate, every surveyor's plot, every land title drawn from a compass bearing carries an implicit assumption about declination. When the field changes, all of those documents quietly start being wrong and somebody has to go update them. So, the record. From 1831, when Ross found it, to 1904, When the next explorer went out and physically repeated the measurement, the pole moved at an average rate of about 0.76 kilometres per year. Let me put that in perspective. Over 73 years, it covered a distance you could walk in about a fortnight. For all practical purposes, in an era when navigation depended entirely on magnetic compasses, the pole was standing still. From 1904 to 1948, it picked up to roughly 9 kilometres per year. That is a 12-fold increase, which sounds dramatic until you consider it is still slow enough that a chart printed at the start of a sailor's career would still be roughly usable at the end of it. Through the middle of the 20th century that held 9 kilometres a year, then 11. From 1984 to 1994, about 15. A slow, steady, gentle acceleration across 160 years, exactly the kind of thing you would expect from a system with enormous inertia gradually shifting its state. Nobody was alarmed. This is textbook secular variation, which is the technical name for the slow ongoing change in Earth's magnetic field, and every survey and navigation authority on the planet had built procedures around it. Each of those numbers, by the way, was earned. These were not model outputs. Somebody physically travelled to the high Arctic, hauled a dip circle across the ice, and found the spot where the needle pointed at the centre of the Earth. The record I am reading you is a record of expeditions, and the reason it exists at all is that a series of people decided a dot on a map in the middle of nowhere was worth a season of frostbite. Now all of that is prologue, and I have laid it out at length for one reason. You need to feel how boring the first 160 years were in order to feel what happened next. Because in the middle of the 1990s, the North Magnetic Pole did something it had never done in the entire history of the measurement, and the explanation for it when it finally arrived was not that something reached out and grabbed it. Part 5. The year the pole broke into a run. In 1994, the pole's speed jumped from about 15 kilometres per year to roughly 51.5. That is not a trend continuing. That is a factor of 3.5 in a single step, and it landed inside a dataset whose entire prior history was measured in single digits. It kept going. The interval spanning the early 2000s averaged about 54.6 kilometres a year. Around 2010, the rate peaked near 58.1 kilometres per year, which remains the fastest sustained migration of the North Magnetic Pole in the whole instrumental record. 58 kilometres a year is about 36 miles. It is not a pace you would notice standing in the Arctic, but it is a pace that breaks things. It broke navigation charts. It forced aviation authorities to reissue runway designations at airports, because runway numbers are based on magnetic heading, and the magnetic headings were drifting out from under them. It forced the model that governs global magnetic navigation into an unscheduled, out-of-cycle update, which had essentially never happened before. Total displacement since Ross planted his flag, more than 2,200 kilometres. The pole left the Canadian Arctic, crossed out of the Canadian hemisphere entirely, walked into the central Arctic Ocean, and is now closer to Siberia than it is to Canada. I want to make the disruption concrete, because it is easy to hear the pole moved and picture nothing at all changing in the world you live in. The model that governs magnetic navigation worldwide is called the World Magnetic Model, and it is produced jointly by the National Centres for Environmental Information at NOAA and the British Geological Survey, with the National Geospatial Intelligence Agency as a release partner. It is designed to be issued every 5 years, with each edition carrying a rate of change built in so it stays accurate across its lifetime. That 5-year cadence worked for decades. Then the pole started moving fast enough that an edition went out of tolerance before its expiry date, and the agencies had to publish an unscheduled release in the middle of a cycle. That is the bureaucratic equivalent of a fire alarm. It means the drift had outrun the correction terms, and it means aviation, marine navigation, defence systems, and every consumer device with a magnetometer in it were quietly working from a model that had drifted out from under them. Airports felt it too, in a way that sounds almost comically mundane. Runway numbers are derived from magnetic heading, rounded to the nearest 10 degrees. A runway pointing at a magnetic bearing of 184 degrees is runway 18. When declination shifts far enough, that same strip of concrete now points at 175 degrees, and it becomes runway 17. Which means somebody has to repaint the numbers on the tarmac, reissue the charts, update the approach plates, and retrain the controllers. Airports in the high latitudes have done exactly that, more than once, because the field under them moved. The current position, according to the 2025 edition of that model, is 85.762 degrees north, 139.298 degrees east. Look at that first number for a moment. 85.76 degrees north. The geographic pole is at 90. The magnetic pole is currently sitting a little over 4 degrees of latitude from the top of the world, out in the central Arctic Ocean. Hold that thought because it is going to matter enormously later, and it is the single most misunderstood fact in this entire subject. So the obvious question is what pulled it? And for years, the popular framing has been exactly that. Something in Siberia is dragging the magnetic pole toward Russia. It is a satisfying image. It is also wrong, and the actual explanation is better because it turns the whole story inside out. Here is what the published work says is happening. At the boundary between Earth's core and its mantle, roughly 2,900 kilometres down, the magnetic field is not smooth. It is concentrated into patches, and 2 of those patches are enormous. One sits beneath Canada, one sits beneath Siberia. Both are regions of intense magnetic flux, and between them they largely determine where the surface pole ends up, because the surface pole is essentially the compromise position between 2 competing pulls. For a century and a half, the Canadian patch was winning. That is why Ross found the pole on the Boothia Peninsula and why it stayed in the Canadian Arctic for generations. Then, sometime between roughly 1970 and 1999, the flow of liquid iron in the core changed in a way that stretched the Canadian patch out and weakened it. It did not vanish. It got smeared and diluted, and it stopped being able to hold its side of the argument. The pole did not run towards Siberia. It was released. Sit with that for a second, because it changes what kind of story this is. If something in Siberia had reached out and grabbed the pole, you would be looking at a new force appearing somewhere. Instead, what happened is that a structure that had been holding steady for as long as anyone had measured it quietly lost its grip, and the pole rolled downhill toward the thing that had been there the whole time. Nothing was added. Something failed. And once you know that, the acceleration stops looking like an escalation and starts looking like a collapse, which is a completely different diagnostic. An escalation implies an increasing input. A collapse implies a structure that had a limit and reached it. Nobody knows why the Canadian patch stretched. Nobody knows what changed in the core flow between 1970 and 1999. We know it happened because the pole told us, in the only language the core has, which is exactly the point I made earlier. The pole is a dashboard readout, and in the 1990s the needle jumped. There is a detail here that I find genuinely hard to get past. The change in core flow that released the pole was happening during the 1970s and 1980s. We only found out because of what it did to the surface position in the 1990s. The deep interior of this planet reorganized something, and the entire human species learned about it from a lag, after the fact, from a measurement taken with a needle. There is no camera down there. There is no sensor down there. There never will be. Everything we know about the inside of this planet we know from what it does to the outside. Now this is normally where an explainer would stop, having delivered a satisfying mechanism, but the record does not stop in 2010, and what happened next is, to me, the single most interesting number in this entire subject, and it gets almost no coverage at all. After peaking near 58 kilometres a year, the pole slowed down. It dropped to about 53.6, and it has continued slowing. According to the National Centres for Environmental Information at NOAA, which co-produces the model that governs global magnetic navigation, the recent drift rate is around 35 to 36 kilometres per year. That is a reduction of roughly 40% from the peak. And it is not just a slowdown, it is the largest deceleration in pole speed ever measured. Think about what that means in terms of the release story I just told you. A structure in the core let go, the pole accelerated fourfold across 2 decades, and then, without anyone predicting it, the acceleration reversed and the pole began to break hard. Whatever changed in the core flow in the 1970s appears to have changed again, or partially undone itself, or run into something. And here is the honest part. The part I cannot dress up, nobody knows which. There is no accepted explanation for the deceleration. It is a measured fact with a blank space where the mechanism should be. A system that behaves like that is not following a trend. Trends do not accelerate by a factor of 4 and then break by 40%. A system that behaves like that has internal structure, and it has changed state at least twice inside a single human lifetime, which means the interesting question about Earth's magnetic field is not whether it is weakening, because that framing turns out to be badly incomplete. The interesting question is what is actually happening in there, and to answer that, you have to stop looking at the pole's position and start looking at the field's strength, region by region, across the whole planet. When you do that, you find something that almost no coverage of this subject will tell you, and it points in the opposite direction from everything you have been led to expect. Part 6. The deceleration nobody can explain. There is a rule of thumb in geophysics that a measurement only becomes interesting when it does something a smooth curve cannot do. A slow rise is a trend. A slow fall is a trend. Trends are comfortable, because a trend implies you understand the direction of travel even if you do not understand the cause. What you're not supposed to see is a system that accelerates fourfold and then, 20 years later, breaks by 40% without being asked. That is what the North Magnetic Pole has done, and I want to spend real time on the break, because it is the part of this story with the least coverage and the largest hole in the middle of it. Reconstruct the sequence in order: 15 kilometres a year through the early 1990s, 51.5 from 1994, 54.6 through the early 2000s, a peak near 58.1 around 2010, then 53.6, and now, per the National Centres for Environmental Information, somewhere in the range of 35 to 36 kilometres per year. Across roughly 15 years, the pole has given back the majority of the speed it gained across the preceding 15, and the agencies responsible for tracking it describe this as the largest deceleration in pole speed ever measured. Now, if the release story is right, and I think it is, then this break is telling us something specific. Remember the mechanism. The Canadian flux patch stretched and weakened between roughly 1970 and 1999, lost its grip, and the pole rolled toward the Siberian patch. That is a story about a competition being decisively won, and a competition that has been decisively won does not usually reverse itself. So there are only a handful of ways to explain a break, and every one of them is interesting. The first possibility is geometric rather than dynamic. As the pole approaches the region dominated by the Siberian patch, the pull it feels from that patch stops being a sideways tug and starts being something more like a direct approach. Anything moving toward the thing that is attracting it slows as the geometry closes, in the sense that the sideways component of the pull shrinks. Under that reading, the break is not a change in the core at all. It is what arrival looks like, and that reading has a testable consequence. If it is right, the pole should keep decelerating and eventually settle somewhere in the vicinity of the Siberian lobe rather than continuing past it. The second possibility is that the core flow changed again. Whatever reorganization stretched the Canadian patch in the 1970s could have partly reversed, or a new pattern could have established itself, and the surface is now reporting the second change the same way it reported the first, with a lag of a couple of decades. Under that reading, the break means the interior is not settling into a new steady state. It is still actively rearranging, and we are watching the second act of something whose first act we only recognized in hindsight. The third possibility is the least comfortable, which is that both of the previous decades were sampling a system with more internal structure than our models capture, and the acceleration and the deceleration are both features of a pattern with a period longer than our measurement record. If that is the case, then the honest statement is that we have been watching for 195 years, and the phenomenon has a rhythm longer than that, and we simply do not have enough of the curve to say what shape it is. I cannot tell you which of those is correct, and neither can anyone else with a straight face. What I can tell you is that the deceleration is real, it is documented by the agencies that build the navigation model, the whole world depends on, and there is no accepted mechanism attached to it. That is a genuinely rare situation in a well-instrumented field. It is a measured fact with a blank space where the explanation goes, and it is the same lesson as before, which is why I keep coming back to it. Every single thing we know about this is inference from the outside. Nobody has been down there. Nobody will go down there. The deepest hole ever drilled into this planet reached about 12.2 kilometres, which is not a fifth of 1% of the way to the core. The entire body of knowledge about the machine that generates the field you are sitting inside is built from surface measurements, satellite measurements, and the magnetic memories locked into old rocks. When that body of knowledge has a gap in it, the gap does not get filled by going and looking. Here is a second asymmetry in the same dataset that almost nobody mentions, and it makes the picture stranger rather than simpler. There are two magnetic poles, and they do not behave the same way at all. Over the recent interval, the northern magnetic pole has been drifting at roughly 36 kilometres per year. Over the same interval, the southern magnetic pole has been drifting at roughly 9. That is a factor of 4 difference between the two ends of what people casually describe as a single bar magnet. If Earth's field were a clean dipole, that could not happen. A bar magnet does not have one end that wanders and one end that mostly stays put. The fact that the two poles move at completely different speeds is direct, everyday evidence that Earth's field is not a simple dipole and never has been. It has a dominant dipole component, which is why compasses work at all, plus a substantial collection of higher order structure, and the two hemispheres carry different amounts of that structure at different times. The two poles are not even antipodal, they are not on opposite sides of the planet from each other. Draw a line from the northern magnetic pole through the centre of the Earth, and it does not come out at the southern magnetic pole. It comes out somewhere else entirely, and the size of that mismatch is one of the standard ways geophysicists quantify how non-dipolar the field currently is. I keep hammering on this because it matters for how you should hear every claim about a pole reversal. When somebody says the poles are about to flip, they are usually imagining a bar magnet rotating, with the north end swinging around to the south. That is not what the record shows happening, and it is not what the field is. What the field actually does during a reversal is break up. The dipole weakens, the higher order structure becomes proportionally more important, multiple poles can appear in each hemisphere, and then eventually the dipole reassembles with the opposite sign. The process is messy, it is slow, and it looks nothing like a rotation. And that is why the deceleration matters beyond its own curiosity value. In the mid-2000s, if you had extrapolated the pole's acceleration forward, you could have drawn a genuinely alarming curve. The pole was speeding up, the dipole was weakening, and if you connected those two facts with a straight line, you got a story about a field falling apart on a human timescale. That line was drawn a great many times, in a great many places, and it is still being drawn. Then the pole braked, and the extrapolation quietly stopped working, and almost nobody went back to correct it. So we need a better way to ask the question, and the better way is not to watch the pole. It is to measure the strength of the field itself, everywhere, continuously, and see where it is going up and where it is going down, which we can now do, because for the last decade a constellation of satellites has been doing exactly that. Part 7. The half of the story nobody reports. In 2013, the European Space Agency launched 3 identical satellites into polar orbit and called the mission Swarm. Their purpose is narrow and unglamorous: fly around the planet with extremely precise magnetometers and build the most detailed continuous map of Earth's magnetic field ever assembled. Not a snapshot. A movie. By 2025, that movie was 11 years long, and researchers published an analysis of the whole thing in the journal Physics of the Earth and Planetary Interiors. It is the single most important dataset in this subject, and it contains 2 findings. One of them has been reported everywhere, the other one has barely been reported at all, and it is the reason I wanted to make this video. The reported finding is the South Atlantic anomaly. This is the great dent in Earth's magnetic shield, a region centered over the South Atlantic and stretching across parts of South America and southern Africa, where the field is dramatically weaker than it should be for that latitude. It is not a hole. The field is still there, but it is thin, and it has been getting thinner and wider for as long as we have been watching. The swarm numbers put hard edges on it. Since 2014, the anomaly has expanded by an area nearly half the size of continental Europe. It has developed a second distinct minimum, a separate pocket of weakness nearer to Africa, so that what used to be described as a single feature now has 2 centres. The weakening on the African side has accelerated since 2020, and the field strength at the very weakest point inside it has dropped from 22,430 nanotesla in 2014 to 22,094 nanotesla in 2025. That is a decline of 336 nanotesla in 11 years, and I want to give you a scale so the number means something. Over most of this planet, field strength runs somewhere between 40,000 and 45,000 nanotesla. The strongest place on Earth is over Antarctica, at around 67,000. So the weakest point in the South Atlantic anomaly is running at roughly a third of the planet's maximum and about half the global average. It is a genuine thin spot. It is real, and the trend line is unambiguous. Now here is the finding that did not travel. In the same dataset, over the same 11 years, the region of strong magnetic field over Siberia grew. Not shrank. Grew. The area of that high-intensity lobe expanded by about 0.42% of Earth's entire surface area, which works out to a region roughly the size of Greenland. And the maximum intensity inside it increased by about 260 nanoteslae. Read those two results next to each other, because that is the only honest way to read them. In the South Atlantic, the field lost 336 nanotesla at its weakest point over 11 years. Over Siberia, the field gained 260 nanotesla at its strongest point over the same 11 years. Those are comparable magnitudes pointing in opposite directions in the same study from the same satellites. Which means the sentence, Earth's magnetic field is weakening, and the sentence, Earth's magnetic field is strengthening, can both be sourced to the same 11 years of data, and the only difference is which hemisphere you point the camera at. One of those sentences gets headlines. The other one does not exist in public conversation at all. Siberia is, as far as the current record shows, the one large region on this planet where Earth's magnetic field is measurably getting stronger. And that fact does something remarkable to the story we have been building because it closes the loop on the release mechanism from the other side. Think about the geometry. There are two great flux patches at the core mantle boundary, one under Canada and one under Siberia. The Canadian one stretched, weakened, and let go of the pole. The Siberian one is the destination. And the swarm data shows that while all this has been happening, the Siberian lobe has been getting larger and more intense. The patch that won the tug-of-war is not merely holding steady, it is consolidating. So the picture is not a field that is fading, the picture is a field that is redistributing. Strength is leaving one part of the planet and appearing in another. The surface pole is being handed from the losing region to the winning one, and the global dipole, which is the average of all of it, is declining slowly while individual regions do dramatic and opposite things underneath that average. Let me be very precise about the global number, because it is the one that gets abused most. Earth's dipole moment has declined by roughly 9 to 10% since systematic measurements began in the 1830s. There is also a figure you will see quoted constantly, that the field has weakened by about 30% over the last 3,000 years. That second number is not an instrumental measurement. It comes from archaeomagnetic reconstruction, which means inferring past field strength from the magnetic signatures locked into fired clay, kiln walls, pottery, and lava flows. That work is real and careful, but it is a reconstruction with error bars, not a reading off a dial, and anyone who quotes it as though it were measured is skipping a step. And there is one more number, and if you take only one thing away from this entire video, I would like it to be this one. Researchers can reconstruct the strength of Earth's magnetic field going back tens of thousands of years, using the same principle. Rocks and sediments record the field they cooled or settled in. When you plot that reconstruction across the last 50,000 years, you find that Earth's field rose to a double peak over the last 3,000 years and has been declining from that peak since. Which is the decline everybody talks about, but the level it has declined to is still high, not average. High by the standards of the last 50,000 years. We came down off an unusually strong episode, and we are still above the long-run typical value. That single fact reframes everything. The field is not in a historically weak state. It is in a historically strong state that is getting less extreme. Those are not the same thing, and the difference between them is the difference between a fever breaking and a body failing. So if the field is strong and the pole is decelerating, and the strength is redistributing rather than draining away, then what exactly is going on? Where is this actually heading? The answer turns out to depend on a question I've not asked yet, and almost nobody asks. Everyone wants to know how fast the pole is moving and whether that is bad. Nobody asks where it is going. Part 8. The Pole That Went Home. 85.762 degrees north. I gave you that number earlier and asked you to hold it. Now I want to unpack it, because it is the fact that broke this story open for me, and once you see it, you cannot unsee it. The geographic North Pole, the point where Earth's rotational axis emerges from the surface, sits at 90 degrees north by definition. The magnetic North Pole is currently at 85.76. That is a separation of a little over 4 degrees of latitude, which is roughly 470 kilometres. Now compare that to where it was when Ross found it. The Boothia Peninsula sits at about 70 degrees north. In 1831, the magnetic North Pole was roughly 20 degrees of latitude away from the rotational axis, which is on the order of 2,200 kilometres, and it was not far from the boundary of the Arctic Circle. So here is the sentence that almost nobody says out loud. Over the last 195 years, the North Magnetic Pole has moved from being badly misaligned with Earth's rotational axis to being almost perfectly aligned with it. It is currently closer to the geographic pole than at any point in the surveyed record. The pole did not run away from anything. In the northern hemisphere, it went home. Now I have to be careful here, because there is a subtlety that most people telling this story get wrong, and it happens to be the single most useful thing in this whole section for understanding the field's real condition. There is more than one thing called a magnetic pole. The one we've been tracking, the one Ross found with a dip needle, is called a dip pole, the place where the field is actually vertical at the surface. But there is a second definition. If you take Earth's field and fit the best simple bar magnet to it, that ideal magnet has an axis, and where that axis emerges from the surface is called a geomagnetic pole. Those two things are not in the same place, and the gap between them is a direct readout of how much of the field is not a simple bar magnet. Right now, that gap is enormous. The dip pole sits at 85.76 degrees north. The geomagnetic pole, the best fit dipole pole, sits at about 80.85 degrees north, 72.76 degrees west, up in the Canadian Arctic, and the axis of the best fit dipole is inclined about 9.2 degrees to Earth's rotation axis. So read those two numbers together, because they say something remarkable. The place where the field is genuinely vertical has walked to within 4 and a bit degrees of the top of the world. The idealized dipole axis is still tilted more than 9 degrees, and it is still pointing at Canada. Those two facts cannot both be explained by a bar magnet. They are only compatible if a large amount of Earth's field is non-dipolar structure, and it is that structure, not the dipole, that has pulled the vertical point up over the pole. Which means the correct reading of the northern situation is not that the field has become a tidier bar magnet. It is that the field's higher order structure has become strong enough to drag the vertical point almost onto the rotational axis, while the underlying dipole stays tilted toward Canada. That is a stranger result than either the reassuring version or the frightening one, and it comes straight off a public agency page. Let that sit against everything you have ever been told about this subject. The framing is always flight, always deterioration, always a shield coming apart, and the actual northern situation is that the point where the field goes vertical has migrated to within a few hundred kilometres of the geographic pole, while the dipole axis stayed tilted, which is not deterioration and is not reassurance. It is reorganisation, and it is happening in a direction nobody advertised. I am not telling you this to make you feel better. I am telling you because the real story is not everything is fine, and it is not everything is falling apart. It is something genuinely stranger, and the southern hemisphere is what makes it strange. Because while all of that was happening in the north, the southern magnetic pole did the exact opposite. The current position of the southern magnetic pole per the same 2025 model is 63.851 degrees south, 135.078 degrees east, 63.85 degrees south. The Antarctic Circle sits at about 66.5 degrees south, which means the southern magnetic pole is not merely far from the geographic South Pole, it is outside the Antarctic Circle entirely. It has left the Antarctic, and it did not start there. In the early 19th century, the southern magnetic pole was comparatively well aligned, sitting substantially closer to the geographic pole than it does now. Across the 20th century it walked outward, drifting from inside the Antarctic Circle to outside it, covering enormous ground while the northern pole was still crawling along at 9 kilometres a year. Look at the timing of those two migrations, because it is the detail that gives me pause. Through roughly the first half of the 20th century, the southern pole was the one moving significantly, and the northern pole was relatively stable. In the second half, and especially after 1994, the northern pole took off, and the southern pole slowed to the 9 kilometres a year we measure today. They took turns, and in doing so, over about 125 years, they effectively traded places geometrically. The hemisphere that used to be lopsided is now aligned. The hemisphere that used to be aligned is now lopsided. That is not what a fading field looks like. a fading field weakens more or less everywhere, and the geometry degrades in both hemispheres together. What we are watching instead is a field that is reorganizing itself, hemisphere by hemisphere, taking strength from one region and giving it to another, straightening out one end while bending the other. And that is the central thread of this entire video. Restated in the cleanest possible form, the honest description of what Earth's magnetic field is doing right now is not decline. It is redistribution, and nobody can tell you what the finished arrangement looks like, or whether there is a finished arrangement at all. Which raises an uncomfortable question that I think is the most important one in the subject. If the field is redistributing, and the northern geometry is improving while the southern geometry degrades, and the South Atlantic thins and Siberia strengthens, then what is the global trend actually made of? Because the global dipole decline of 9 or 10% since the 1830s is a single number computed by averaging all of that regional chaos together, and an average of opposing regional trends is one of the least informative numbers you can construct. It is the geophysical equivalent of reporting the average temperature of a house, where one room is on fire and another has the window open. So the 9% figure is not wrong. It is just far less meaningful than the way it gets used, and the regional numbers underneath it are where the actual physics lives. There is a practical consequence of the northern alignment that shows up in the least glamorous place imaginable, which is on a hiker's compass. When the magnetic pole and the geographic pole are far apart, magnetic declination across the mid-latitudes is large, and it changes quickly as you travel east or west. As the magnetic pole moves toward the rotational axis, the pattern of declination across the northern hemisphere simplifies, because the thing your needle is pointing at and the thing your map is drawn around are converging. Over parts of the northern hemisphere, the correction you have to apply between magnetic and true north has been shrinking for decades. Nobody markets that as good news, but it is a direct, measurable, everyday consequence of the geometry I have just described. There is also a consequence in the sky, and it uses the distinction I just drew. The auroral ovals are not centered on the geographic poles, and they are not centered on the dip poles either. They are closely centered on the geomagnetic poles, the best fit dipole poles, and they sit as bands roughly 5 degrees of latitude wide, with the strongest activity falling between about 15 and 25 degrees away from those poles, displaced somewhat toward the night side, which means when the dipole axis shifts, the aurora shifts with it. Anyone who has spent decades chasing the northern lights at high latitude has been chasing a target that has been quietly changing shape underneath them, and the reason is 3,000 kilometres down. There is one more consequence of the northern pole's near alignment that has nothing to do with reassurance and everything to do with what happens next. A magnetic pole is where field lines converge and plunge vertically into the planet, and that convergence is a funnel for charged particles arriving from space. As long as the pole sat over the Canadian Arctic, that funnel sat over the Canadian Arctic. It is now 470 kilometres from the top of the world, in the middle of an ocean, and moving toward the Siberian shelf, which means the geographic footprint of that funnel is moving, and it is moving towards somewhere specific. We will get to what is waiting there. But first there is a problem with everything I have just told you, and I think you deserve to hear it from me rather than from a comment section. Every position I have quoted you in this section is a model output. Nobody has stood on that spot with a needle in nearly 2 decades. Part 9. Nobody has stood there since 2007. The entire early record of the North Magnetic Pole is a record of people going there. Ross in 1831, hauling a dip circle across the ice on foot, Amundsen and the surveyors who followed. Then, from 1948 to 1994, Natural Resources Canada tracked the pole across the Canadian Arctic by periodically going out and conducting fresh magnetic surveys to re-establish where it had got to. 2 further determinations in 2001 and 2007 came out of an international collaboration led by a French fundraising association called Polyarctique, working with Natural Resources Canada, the Institut de Physique du Globe de Paris, and the Bureau de Recherche Géologique et Minière. Each of those numbers I read you earlier cost somebody a season in the Arctic. That 2007 survey produced a figure worth pausing on. It determined that the pole was moving north-northwest at approximately 55 kilometres per year. That is the last direct boots-on-the-ice measurement of how fast the North Magnetic Pole was travelling, and it was taken at close to the peak of the sprint. Consider what one of those surveys actually involved, because it explains why the record has the shape it has. You cannot find the magnetic pole by standing at one spot. The dip angle changes gradually, So what you do is occupy a series of stations spread across a wide area, measure the dip at each of them with great care, and then work out where the pattern of those measurements implies the 90-degree point must lie. That means multiple camps, multiple instrument setups, hours of careful observation at each one, and all of it in a place where the ice is moving under you, and the weather can shut everything down for a week. A single pole determination was a season's work for a team. That is why the record is a series of widely spaced points rather than a continuous curve. 1831, 1904, 1948, then a run of determinations through the second half of the 20th century as aircraft made the logistics tractable. And every velocity figure I quoted you earlier is not a measured speed at all. It is a distance between two of those fixes divided by the years between them. When I say the pole averaged 54.6 kilometres per year in the early 2000s, that is an average across the gap, which means any short-lived surge or pause inside that gap is invisible. The record has that limitation baked into it, and it is worth knowing before anyone builds a dramatic curve out of it. The last time anyone did that was in 2007. Every position published since then, including the 85.762 degrees north I've been building this section around, is not a survey result, it is a model solution. Satellites like the Swarm constellation measure the field from orbit. Ground observatories measure it at fixed points. All of that data goes into a mathematical description of the global field, and then you ask that description a question: where does this field become vertical? The answer that comes back is the published pole position. I want to be extremely clear that there is nothing improper about this. It is better science than the expeditions were, in almost every respect. A dip circle on the ice gives you 1 point, on one day, with one instrument, at whatever accuracy the conditions allowed. A satellite constellation gives you the entire planet continuously for years. The model built from that is more accurate, more current, and more useful than any single field measurement could ever be. The high-resolution version of the World Magnetic Model released in 2025 carries roughly 10 times the spatial resolution of what came before it. That is not a downgrade. That is a generational improvement. But it does mean that the sentence, "the pole moved," and the sentence, "the model of the pole moved," are not identical, and honest science communication has to acknowledge the gap between them. Here is why I am spending time on this rather than glossing over it. If you do not tell people this, somebody else will, and they will tell them badly. They stopped measuring the magnetic pole in 2007 is a true statement that sounds enormously sinister and has a completely boring explanation. I would rather you hear the boring explanation from me first, so that when the sinister version reaches you, it arrives pre-diffused. The boring explanation, in full, expedition-based point measurements were superseded by satellite magnetometry with global coverage. Fewer trips, vastly more data. The model is public, the satellite data is public, the code is documented, and the agencies that produce it publish annual reports on how well it is performing against observation. There is no locked drawer. That last piece deserves a moment, because it is the part that makes the whole arrangement auditable. Every year, the agencies that maintain the World Magnetic Model publish a report comparing the model's predictions against what the observatories and satellites actually recorded over the preceding 12 months. The model has a specified error budget, and the annual report is where you find out whether it stayed inside it. A model that is drifting out of tolerance shows up in that document before it shows up anywhere else, and that is precisely how the mid-cycle emergency release I mentioned earlier came to happen. The system that caught the problem was the system designed to catch the problem, working in public, on schedule. This matters for how you should think about the next few years of this story. If the pole reaccelerates after its record deceleration, the first public evidence will not be a viral post. It will be a line in an annual performance report showing the model's declination predictions falling outside their stated tolerance in the high Arctic. That is a boring, checkable, publicly available document, and it is the actual early warning system for the thing everybody is worried about. There is, however, a genuine and interesting complication, which is that the pole has made itself much harder to visit. Ross found it on land, on the Boothia Peninsula. You can walk to a peninsula. The pole is now out in the central Arctic Ocean, which means any direct measurement today requires either an icebreaker, an ice camp, or aircraft operating over sea ice at 86 degrees north. That is not impossible. It is expensive, logistically demanding, and difficult to justify when a satellite constellation is already doing the job better. So the honest situation is this. We have excellent, continuous, high-resolution knowledge of Earth's magnetic field, and we have not physically verified the location of the North Magnetic Pole against a needle on the ground since 2007, and the reason for that is a mix of good science and mundane logistics rather than anything else. Both halves of that sentence are true, and they belong together. And here is what I find genuinely tantalizing about it. If somebody did go and did plant a dip circle at 85.762 north, 139.298 east, and the needle did not point straight down, that would be a significant scientific result. Not because anything is being hidden, but because the difference between the model and the measurement is exactly where new physics shows up. Every discrepancy between a prediction and an observation is an opportunity, and in this particular case, that opportunity has been sitting unclaimed on a patch of Arctic sea ice for almost 20 years. Which brings us finally to the claims, because so far everything I have told you is measurement. The pole's speed, its position, the intensity map, the redistribution, the deceleration, all of it comes from instruments and models that anyone can inspect. The moment we step from those facts to the question of what they cause, we leave the measured world. And the most popular answer to that question, the one currently circulating hardest, is built on a body of real scientific literature that says almost precisely the opposite of what it is being cited for. Part 10. The claim that runs backwards. The claim goes like this. Earth's magnetic field influences volcanism, and the proof is Italy. Italy's volcanoes have been studied in relation to the magnetic field for decades. The research exists. You can look it up, and therefore the changes we are seeing in the field right now explain why Etna has been erupting for 2 weeks, and why Campi Flegrei just produced its largest earthquake in 40 years. I want to take that claim seriously, because it is the most sophisticated-sounding version of the magnetic cause argument, and because the person making it is usually right about the most important part. There really is a substantial body of scientific literature connecting Italian volcanoes to Earth's magnetic field. It is not invented. It is not fringe. It is in journals like Geophysical Journal International. It goes back decades, and it involves exactly the volcano's people name, Etna, Vesuvius, and Mount Arso on the island of Ischia. And when you actually read it, the arrow is pointing the other way. Here is what that literature does. When lava erupts, it comes out of the ground at temperatures well above a threshold called the Curie point, which is the temperature above which a material cannot hold a magnetic orientation. As that lava cools past the Curie point, magnetic minerals inside it, mostly iron oxides, align themselves with whatever magnetic field is present at that moment and then lock in. The rock freezes, and in freezing, it takes a photograph of Earth's magnetic field on the day it erupted, direction and intensity preserved in stone. Now consider what makes Italian volcanoes special for this purpose. It is not their chemistry, and it is not their eruptive style. It is their paperwork. Italy has continuous written records going back 2,000 years, which means a great many Italian lava flows have known eruption dates. Somebody wrote down that Vesuvius erupted in a specific year, and there is a flow on the ground from that year, and inside that flow is a locked-in record of the magnetic field on that date. That combination is extraordinarily rare and extraordinarily valuable. It means you can build a calibrated timeline of Earth's magnetic field, century by century, from physical rock samples with independently known ages. And that is precisely what the literature did. Measurements of magnetization, direction from lava flows at Mount Arso on Ischia, at Etna, and at Vesuvius were found to trace a common path, and that path was named the Southern Italy Secular Variation Curve. Separate archaeointensity work from Italy, using fired archaeological materials alongside the volcanic record, reconstructed the strength of the field across roughly the last 3,000 years. So the relationship between Italian volcanoes and Earth's magnetic field is real, well-established, and heavily published. The volcanoes are the instrument. The field is what is being measured. The information travels from the field into the rock at the moment the rock cools, and then sits there for 2 millennia, waiting for somebody with a magnetometer to come read it. That is the exact opposite of the claim. The claim says the field drives the volcano. The literature says the volcano records the field. And notice how easy that mistake is to make. If you search for research connecting Italian volcanoes and geomagnetism, you will find a large pile of legitimate papers, and if you do not read past the titles, the pile itself looks like the answer. "There's tons of research linking Italy's volcanoes to the magnetic field" is a true sentence that supports a false conclusion. This is why I keep saying the failure mode is not noticing things, it is stopping at the noticing. Now, having said all that, I'm not going to pretend the underlying question has been answered, because it has not. Whether large-scale changes in Earth's magnetic field can influence volcanic or seismic behaviour remains genuinely open. It is not a settled no. It is an unanswered question with no established mechanism, and the distinction between those two things is worth respecting. So let us ask the mechanism question directly, because that is where these arguments live or die. What would actually have to happen for a magnetic pole 470 kilometres from the geographic pole to change the behaviour of a magma chamber in Sicily? You would need energy delivered into that chamber, and you would need enough of it to matter. A magma body sitting under pressure is held in equilibrium by enormous forces. The weight of the rock above it, the strength of the surrounding crust, the pressure of dissolved gas within it. To tip that equilibrium, you need to add or remove a meaningful fraction of those forces. Magnetic fields do exert forces, but the energies involved in a shift in the position of a surface magnetic pole are, by any accounting anyone has published, orders of magnitude too small to register against the mechanical state of a magma reservoir. Nobody has published a mechanism that closes that gap, and the reason is that the gap is not close. This is the same test that decides every trigger claim: run the energy budget. It is a boring calculation, and it settles arguments that rhetoric cannot. The Kamchatka case passed that test because a magnitude 8.8 earthquake genuinely does deliver enormous mechanical energy into the surrounding crust, and volcanoes a few hundred kilometres away genuinely do feel it. The magnetic case fails it, not because the idea is stupid, but because the arithmetic does not work. But here is where the story turns again, because there is a place in the literature where geomagnetic change and volcanism do appear together, and it is not in the ordinary drift we have been discussing. It is in excursions and reversals. Earth's magnetic field has flipped polarity many times. At least 183 reversals are recorded in the last 83 million years, and during particularly chaotic intervals the rate has reached as high as 26 reversals per million years. The most recent full reversal, called the Brunhes-Matuyama transition, happened roughly 780,000 years ago. Since then there have been around 15 excursions, which are partial events where the field weakens dramatically and wanders, but then returns to its original polarity rather than completing the flip. The best known of those is the Lachaume excursion, about 41,000 years ago. Two facts about those events are essential, and almost always omitted. First, they are slow. The Brunhes-Matuyama reversal took at least 22,000 years to complete. That is not an event a civilization experiences. That is an event a civilization's entire recorded history fits inside a fraction of. Second, the field never goes to zero. It weakens substantially and it becomes multipolar, meaning the clean two-pole arrangement breaks down into something more complicated, with multiple regions of inward and outward flux, and then eventually it reassembles. At no point is the planet unshielded. It is around those events, when the field is weak and disorganized for millennia at a stretch, that the paleomagnetic and volcanic records show more volatility, and that is the legitimate scientific home of the idea that magnetism and volcanism are linked. So the intellectually honest version of the claim is not, the pole is moving, therefore volcanoes. It is during excursions, when the field is deeply weakened for thousands of years, the volcanic record looks different, and the open question is why. That is a real question. It is just an entirely different question from the one being asked about August of 2026, and the difference is the whole point of this section, because the field right now is not in an excursion, is not close to excursion strength, and is sitting high against the last 50,000 years. Which leaves one more claimed mechanism standing, and this one has something the magnetic claim does not. It has a peer-reviewed paper with a real statistical result in it. Part 11. What the Sun has to do with it. The second claim is about the Sun, and it is more interesting than the first because it is closer to being right. The argument runs like this. Solar activity rises and falls on a cycle of roughly 11 years. At solar maximum, the sun is brighter, more active, and emits proportionally more high-frequency light, which charges up Earth's ionosphere and drives electrical currents through the crust and mantle. That process loads energy into the planet. Then, as the cycle descends towards solar minimum, that loading eases, and the statistical record shows global volcanism ticking upward. We are currently on the descending side of solar cycle 25, which was an energetic cycle. Therefore, the next several years should be more volcanically active. The first thing to say is that there is a real paper behind this. Richard Stothers published an analysis in the Journal of Geophysical Research Solid Earth in 1989 titled simply Volcanic Eruptions and Solar Activity. He examined the historical record of volcanic eruptions from 1500 to 1980 and searched it for periodicities. He found two, one at approximately 11 years, matching the solar cycle, and one at approximately 80 years, matching a longer solar modulation. And he found that eruption frequency increases around the times of solar minimum and decreases around the times of solar maximum. That is a genuine, published, peer-reviewed result, and anyone who tells you the solar volcanic idea has no scientific basis has not read it. Now read the qualifiers, because they are doing the heavy lifting and they get dropped every single time this paper is cited. Stothers described the periodicities as weak, and as probably statistically significant. He described the increase near solar minimum as slight. Weak, probably, slight. That is not a hedge inserted for politeness. That is the actual size of the effect. It is not a factor of 10. It is not a doubling. It is a modest modulation detectable in a 480-year catalogue, and the honest way to state it is that the timing of eruptions appears to be very slightly nudged by something that tracks the solar cycle, and there is a serious problem with the dataset itself that has to be stated. That catalogue is a historical record of eruptions, which means it is a record of eruptions somebody noticed and wrote down. For most of the period it covers, an eruption in a remote part of the Pacific or Alaska, or the Southern Ocean, or the Kamchatka Peninsula, or the Andes above the tree line, would go entirely unrecorded unless a ship happened past. Catalogue completeness improves dramatically across the 20th century as instrumentation and global communication improve, which means the density of recorded eruptions in the data is partly a measure of how well the world was being watched. Correcting for that is difficult, and it biases exactly this kind of periodicity analysis in ways that are hard to fully remove. None of that makes the result wrong. It makes it fragile, and fragile results are supposed to be described as fragile. You will also encounter much stronger numbers, and I want to handle them carefully rather than either endorsing them or waving them away. There is analysis reporting an inverse correlation of minus 0.72 between 500-year average sunspot numbers and 500-year totals of large magnitude eruptions, with a probability value of 0.002. There is other work reporting a correlation of minus 0.84 between volcanic frequency and a reconstructed curve of the Sun's background magnetic field across 11 cycles after 1868, with the suggestion that eruption maxima cluster in cycles of a particular magnetic polarity. Those are strong-sounding numbers. They also appear in venues of varying rigour, and a correlation computed on 500-year averages has very few independent data points in it, which makes an impressive-looking probability value much less impressive than it appears. My position is that these should be described to you as claims in the literature rather than findings, and that the responsible anchor for the whole idea remains the 1989 paper with its weak, probable, slight effect. Now, the mechanism. Because a correlation without a mechanism is a starting point, not a conclusion, and this is where I want to apply the same test that sank the magnetic claim. The proposed chain has several links. Solar maximum increases total, and high-frequency solar output. That output ionizes the upper atmosphere more strongly, changing the conductivity and current systems of the ionosphere. Those changing currents induce electrical currents in the conductive rock of Earth's crust and mantle, which is a real and well-documented phenomenon, and those induced currents, over the course of a cycle, do something to magma systems that are already close to failure. Every link in that chain is real except the last one, and the last one is where the entire argument lives. Induced currents in the crust are measurable, and they matter enormously for things like power grids and pipelines during geomagnetic storms. What has never been demonstrated is that the energy involved is remotely comparable to the mechanical and thermal energies governing whether a magma chamber erupts. It is the same energy budget problem as before, in a different costume. So where does that leave us? With a weak, possibly real statistical nudge in a flawed historical catalogue, and a proposed mechanism whose final step is unquantified, that is enough to justify curiosity and enough to justify further study. It is not enough to forecast anything, and it is certainly not enough to explain a specific 2-week stretch in August of 2026. And I want to close this section by connecting it back to why we are here, because it would be easy to walk away from these 2 audits thinking the answer is nothing is happening. That is not the conclusion. Both of the popular explanations for the August cluster fail, one because its evidence points backwards and one because its effect size is too small to carry the weight being put on it. But the thing that made me start reading in the first place, the pole's velocity record and the redistribution of field strength across the planet, does not fail. It is measured, it is documented, it is unexplained in at least 2 specific places, and it survives every test I have been able to throw at it. The claims built on top of it collapsed. The foundation did not, which means we can now ask the question nobody has been asking, and the answer is a place on a map. Part 12. 22,000 years of walking this road. Before we go to the place, I owe you the single most important piece of context in this entire subject, and it is the piece that determines whether everything I have told you is alarming or merely fascinating. The question is simple. Has the pole done this before? Because if the answer is no, if the sprint from Canada to the Central Arctic Ocean is genuinely unprecedented in the planet's behaviour, then we are watching something new and all bets are off. And if the answer is yes, if this route has been walked before and walked at speed, then the pole's current run is a repetition rather than a rupture, and the honest thing to do is say so plainly. The answer is yes. And the way we know is one of my favourite pieces of scientific method anywhere. Remember the principle from the Italian lava flows: a material that cools or settles in the presence of a magnetic field records that field. Lava does it by cooling through the Curie point. Sediment does it a different way. Imagine a lake or a quiet stretch of seafloor where fine particles are slowly settling out of the water column. Some of those particles are magnetic, and as they drift down, before they are locked into place by the accumulating mud above them, they tend to rotate into alignment with the ambient field. Layer by layer, year by year, the sediment builds up a stack of tiny compass needles, each frozen at the moment its layer was buried. Drill a core out of that sediment, keep track of which way is up, and you can read the direction of Earth's magnetic field at that location backward through time. Date the layers, usually using radiocarbon or tephra from known eruptions, and you have a timeline. Do it at multiple sites across a region, and you can reconstruct not just the local field direction, but the implied position of the pole itself. That work has been done extensively in the Arctic, and it is worth naming a few of the records because they are the load-bearing evidence here. A 21,000-year sequence of paleomagnetic secular variation has been recovered from Cascade Lake in the north-central Brooks Range of Arctic Alaska. A record covering the last 6,000 years has been recovered from North Greenland near 81 degrees north. Cores from the Barents Sea Shelf and Slope carry records spanning roughly the last 15,000 years, and the results from Arctic sites are considered particularly valuable precisely because they sit near the magnetic pole, where small changes in the field produce large, readable changes in direction. Here is what those reconstructions show. Over roughly the last 22,000 years, the magnetic pole has traced paths back and forth between the Canadian and Siberian shores of the Arctic. Not a random walk, not a straight line either. Something closer to a loose circulation, wandering across the Arctic basin, sometimes lingering, sometimes covering distance quickly, repeatedly making the crossing in both directions. Reconstructed pole migration over the last 6,000 years is described in the literature as consistent with paleomagnetic, secular variation on geological timescales, which is the technical way of saying what the pole is doing right now is inside the range of what the pole has been doing for as long as the sediment has been recording it. Sit with the shape of that for a moment, because it changes the emotional register of everything. The pole did not leave Canada. It is doing a lap. It has done this lap before. It will do it again. Ross found it on the Boothia Peninsula in 1831, and everyone since has treated Canada as the pole's home address. But that is an artifact of when we happened to invent the instruments. We started watching during one part of a cycle much longer than our watching, and we mistook a position for a residence. There is a paper title I love for how neatly it captures this, published in 2022. A tug of war over the North Magnetic Pole. That is exactly the right frame. Not a flight, not a collapse, a contest, with two competitors that have been trading advantage back and forth for at least 22,000 years, and we happened to be born during a period when one of them was winning. Now hold that against the intensity story, because the two fit together and the fit is the resolution of this entire video. We can reconstruct field strength as well as direction, using the same materials and a related set of techniques, and the standard measure is something called the virtual axial dipole moment. When you plot that quantity across the last 50,000 years, with the conventional 0 point set at 1950, you see the field rise to a double peak across the last 3,000 years and then decline from that peak. That decline is the 9 to 10% since the 1830s, and the roughly 30% over 3 millennia that gets quoted constantly. And the level it has declined to is still high by the standards of the last 50,000 years. I said earlier that this is the one number I would want you to keep, and here is why. There are two completely different stories you can tell with a declining measurement. In the first story, a quantity is falling toward a dangerous threshold, and the decline is the approach to failure. In the second story, a quantity spent a while unusually high, and it is now coming down toward its own normal. The graph looks identical in both cases. The only way to tell them apart is to know where the long-run typical value sits, and for Earth's magnetic field over the last 50,000 years, the long-run typical value is below where we are now. We are not approaching an unprecedented low. We are descending from an unusual high, and we happen to have invented magnetometers and satellites and global scientific communication during the descent from that high, which means every instrument humanity has ever built to measure this has been reading a falling number since the day it was switched on. Now let us put the reversal record in its proper place, because it is the last piece of the honesty framework. At least 183 polarity reversals are recorded in the last 83 million years. During chaotic intervals, the rate has reached 26 per million years, which averages to 1 every 40,000 years or so. During other intervals, the field has held one polarity for tens of millions of years without flipping once. It is not a clock, there is no schedule, and there is no overdue. The last full reversal was roughly 780,000 years ago. Since then, around 15 excursions, including Lashamp about 41,000 years ago, and the Brunhes-Matuyama reversal took at least 22,000 years to complete, during which the field weakened and went multipolar but never vanished. So when somebody tells you a reversal is imminent, the right response is a series of specific questions. Is the dipole below its long-run typical value? It is not. Has the field gone multipolar, with multiple poles appearing in a hemisphere? It has not. Is the northern geometry degrading? It is currently the most axial it has been in the surveyed record. Is the pole accelerating? It executed the largest deceleration ever measured. Has the pole taken a path it has never taken before? It has walked this route repeatedly for 22,000 years. Every single diagnostic points the same way, which is that what we are watching is ordinary secular variation running unusually hard in one particular place, observed by the best instruments ever pointed at it. And that finally is why the destination matters so much. Because if the run to Siberia is normal, then the thing that makes this moment genuinely remarkable is not the movement at all. It is the coincidence of where the movement is currently aimed. And the coincidence is not spiritual, and it is not designed, and it is not causal. It is just extremely strange. Two systems that have no way of communicating with each other, operating on completely different physics, on completely different timescales, are converging on the same set of coordinates in the middle of the Arctic Ocean sometime in the 2030s. One of them is the magnetic pole, released from Canada by a change in the flow of liquid iron. The other one is the slowest moving piece of tectonic machinery on this planet, and it does something that should be physically impossible. Part 13. The strangest ridge on Earth. Draw a line on a globe from the northeast coast of Greenland, straight across the Arctic Ocean, past the North Pole, and down to the Laptov Sea on the Siberian shelf. That line is a mid-ocean ridge, which means it is a place where two tectonic plates are pulling apart, and new seafloor is being created in the gap between them. It is called the Gackel Ridge, and it is the northernmost segment of the global mid-ocean ridge system, the enormous seam that runs like a stitched scar for tens of thousands of kilometres through every ocean basin on this planet. It is also the slowest one, not slow among the slow, the slowest known spreading centre on Earth. Most mid-ocean ridges open at somewhere between 5 and 15 centimetres a year, and the fast ones in the Pacific manage more. The Gackel Ridge, especially at its eastern end approaching Siberia, opens at less than a centimetre a year in places. It is separating at roughly the rate your fingernails grow, and it has been doing so for tens of millions of years. And the pole is headed straight for it. Let me be precise about that, because it is the load-bearing geographic claim of this entire video. The current position of the North Magnetic Pole is 85.76 degrees north, 139.3 degrees east. The pole is moving roughly north-northwest to north at around 35 to 36 kilometres per year, on a trajectory carrying it across the Arctic Ocean toward the Siberian side. The Gackel Ridge crosses precisely that region of the Arctic Ocean, with its eastern segments running toward the Laptov sea shelf in the general longitude range the pole is occupying. Extend the present trajectory forward without any substantial change, and the pole tracks across the Gackel trend in roughly the 2030s. Nothing about that is causal. I want to say it flatly, one more time, so there is no confusion. The pole's route is determined by the flow of liquid iron in the outer core. The Gackel Ridge's position is determined by the geometry of plate motion. These two systems do not exchange information. Neither one is aware of the other. The convergence is a coincidence of route, and if you found it meaningful in a cosmic sense, the arithmetic would be against you, because any pole crossing the Arctic Ocean from Canada to Siberia is going to cross the Gackel Ridge, for the simple reason that the Gackel Ridge crosses the Arctic Ocean. There is no way to make that trip without meeting it. But the coincidence is still worth everything, and here is why. It points at a place almost nobody has heard of, and that place turns out to be doing something that should not be possible. Because ultra-slow spreading does not just mean less volcanism, it means different volcanism. And the Gackel Ridge produced in 1999 one of the strangest volcanic events in the modern seismic record. Here is what happened. Starting in 1999, seismological observatories around the world began recording earthquakes from a segment of the Gackel Ridge at roughly 85 degrees north, 85 degrees east. That in itself is unusual, because a remote patch of Arctic seafloor under permanent ice cover is not a place where global networks pick up much of anything, and to be detected teleseismically an event has to be reasonably substantial. By the time it ended, 252 events had been recorded, with magnitudes between 3.1 and 5.2, and it lasted 9 months. I need you to understand how abnormal that duration is. Earthquake swarms at mid-ocean ridges are a well-known phenomenon. They happen when magma moves into a segment and the crust cracks to accommodate it, and they typically run for a few days to a few weeks and then stop. 9 months is not a longer version of that. 9 months is a different category of event. It is, on the record, the strongest spreading related earthquake swarm ever instrumentally recorded anywhere in the global mid-ocean ridge system. The world's most powerful ridge swarm happened on the world's slowest ridge. That is the sentence that made me stop and read everything I could find, because on the face of it, it is backwards. The place with the least magma production per year produced the biggest magmatic seismic event we have ever recorded on a ridge. It took years to work out what had happened, partly because you cannot simply sail to 85 degrees north and look. It requires an icebreaker and a specialised expedition. When those expeditions did go, they found two things. The first was volcanoes. Seamounts were mapped along the affected segment, and two of them, named Odin and Loke, sat in the middle of the story. The second finding was the one that should not have been there. Odin and Loke were covered with a light dusting of pyroclastic material, and pyroclastic material was found scattered across the wider survey area. Pyroclastic means fragmented. It means the rock was blown apart rather than flowing. It is the product of explosive eruption, the shattered debris that comes out of a volcano when dissolved gas comes out of solution violently enough to tear the magma into pieces on the way out. That is not supposed to happen 4 kilometres underwater. The reason is pressure. Under 4 kilometres of seawater, the ambient pressure is roughly 400 atmospheres. Explosive eruption depends on dissolved gas escaping from the magma and expanding and gas solubility rises with pressure. At 400 atmospheres, gas that would happily fizz out of a magma at the surface stays dissolved. This is the same reason a sealed bottle of carbonated water is quiet and an open one is not. Deep ocean eruptions were long expected to be effusive, oozing rather than exploding, precisely because the ocean sits on top of them like a lid. So how did the Gackel Ridge tear its own magma to pieces under 4 kilometres of water? The answer, published in Nature Communications in 2022, comes back to the spreading rate, and it is one of the most satisfying pieces of causal reasoning in modern marine geology. Here is the chain, step by step. Because the ridge spreads so slowly, the mantle beneath it rises slowly, which means it does not decompress as much or as fast as it does under a normal ridge. Less decompression means less melting. So the mantle under the Gackel Ridge produces what is called a low-degree melt, meaning only a small percentage of the rock melts. Now here is the crucial part. Volatiles, meaning carbon dioxide and water, are what geochemists call incompatible. When rock partially melts, volatiles strongly prefer to go into the liquid rather than stay in the solid, which means when you melt a small fraction of a rock, all the volatiles from the whole volume crowd into that small fraction of liquid. The less you melt, the more concentrated the volatiles in the melt become. Low-degree melting therefore produces magma that is unusually rich in dissolved gas. The mantle beneath the Gackel Ridge is also relatively cool, which reinforces the effect. And because the magmatic system is confined to narrow segments along an otherwise magma-starved ridge, those volatile-rich melts get focused into a small number of reservoirs rather than being spread thinly along the whole length. Put it together, and you get a magma so loaded with dissolved carbon dioxide that when it finally reaches the seafloor, 400 atmospheres of pressure is not enough to keep the gas in solution. The lid is not heavy enough, it explodes anyway. That is what the pyroclastic dust on Odin and Loki is. It is the debris of an eruption that the pressure at that depth should have been able to suppress, made possible by the fact that the ridge is too slow to melt properly, and the system is not finished. Another swarm occurred in the same region in February of 2018. The Gackel Ridge is not a fossil. It is an active, volatile-charged, explosive volcanic environment sitting under permanent Arctic ice cover in one of the least accessible and least monitored places on the surface of this planet. Now put the two halves of this video together, and I think you will see why I found this worth 2 hours of your time. Earth's magnetic North Pole was released from Canada by a change in the flow of liquid iron in the outer core sometime between 1970 and 1999, ran across the Arctic Ocean faster than it has ever been recorded to move, then braked harder than it has ever been recorded to brake, for reasons no one can currently explain. Its present trajectory carries it, in about a decade, across a stretch of Arctic seafloor that spread slower than anywhere else on the planet and that once produced 252 earthquakes over 9 months and blew its own magma apart under 4 kilometres of water. Neither of those facts causes the other. Both of them are real. And the place where they meet is a spot on the map that essentially nobody was paying attention to until the coincidence pointed at it. That is what a pattern actually looks like when you check it properly. Not a hidden hand, not a design. 2 unrelated systems whose paths happen to cross, and a genuinely extraordinary location revealed by the crossing. And there is one more thing about a magnetic pole arriving somewhere, and it is the part that has real, physical, measurable consequences. Because a pole is not just a dot, it is a doorway. Part 14. What a moving pole actually does to you. Everything I have described so far is either measurement or coincidence. Now I want to give you the consequence because there is one. It is real. It is happening, and it has nothing to do with volcanoes. Start with what is arriving. This planet is being hit constantly by charged particles. Some of them come from the sun as the solar wind, a continuous outflow of protons and electrons streaming past us at hundreds of kilometers per second. Some of them arrive in bursts when the sun erupts, and some of them come from very much further away, accelerated by supernovae and by processes near the center of our galaxy and beyond it, arriving with energies that dwarf anything the sun produces. Those are called galactic cosmic rays. The critical property of all of them is that they are particles, not light. A photon has no charge and no rest mass, and it travels in a straight line regardless of what magnetic fields it passes through. A proton has charge and mass, and that changes everything, because a charged particle moving through a magnetic field feels a force perpendicular to its motion. It cannot go straight. It spirals along field lines instead, which means Earth's magnetic field is not a wall. It is a set of rails. Charged particles arriving at this planet do not bounce off a shield. They get steered, and where they end up is determined by the geometry of the field they encounter. Two consequences follow, and both of them are already visible in the data. The first is that where the field is weak, particles get closer to the surface before they are turned. That is the practical meaning of the South Atlantic anomaly, and it is why that feature is a working engineering problem rather than an abstraction. The inner Van Allen radiation belt, which normally sits well above us, dips to around 200 kilometres altitude in that region. 200 kilometres is below the orbit of the International Space Station. It means spacecraft passing through that longitude and latitude band fly through a radiation environment they do not encounter anywhere else on their orbit. The operational consequences are documented and mundane in the way that serious problems often are. Satellite operators know exactly where the anomaly is and plan around it. Instruments get powered down during transits. Data gaps are scheduled. Single event upsets, which are bit flips and logic errors caused by a single energetic particle striking a semiconductor, cluster in that region. Astronauts aboard the station have reported seeing flashes of light with their eyes closed while passing through it, which is a particle interacting with the retina directly. The Hubble Space Telescope has had science observations planned around it for decades, and that thin spot has lost 336 nanotesla at its weakest point in 11 years, expanded by an area approaching half of continental Europe and split into two centres. That is a real trend line on a real operational hazard, and it's the single most defensible reason to care about geomagnetic change, not prophecy, engineering. The second consequence is the one that connects directly to everything we have been building, and it gets almost no attention at all. At a magnetic pole, field lines do not run horizontally past you, they converge and plunge vertically into the planet. And a place where field lines converge vertically is not a barrier to charged particles. It is a funnel. Particles spiralling along those converging lines are guided down toward the surface rather than deflected away from it. That is the fundamental reason the aurora exists at high latitudes and not at the equator. The polar regions are where the rails lead inward. So the polar regions receive a preferential dose of charged particles from space for purely geometric reasons. Not because of anything special about the rock there, because of where the field lines happen to go. And this is where the distinction between the two kinds of pole earns its keep, because the funnel is organised around the dipole axis, rather than around the spot where a dip needle stands vertical. The aurora tracks the geomagnetic poles, the polar cap meaning the region of open field lines connected directly to the solar wind, rather than looping back to the other hemisphere, tracks that same geometry. So when I tell you the funnel is moving, I am not saying it is glued to the dip pole and following it to Siberia step for step. I am saying the whole northern arrangement, dip pole and dipole axis and auroral oval and polar cap, is in motion together, driven by the same core flow changes, and every one of those features is somewhere different today than it was a century ago. Now recall that the pole has moved more than 2,200 kilometres since 1831, and that it is currently moving toward the Siberian shelf at around 36 kilometres a year. The funnel is moving with it. Think about what that means in practical terms. Throughout the 19th and 20th centuries, the geographic footprint of the northern particle funnel sat over the Canadian Arctic. That is where the field lines converged. That is where the auroral geometry was anchored. That is where the preferential flux came down. Over the coming decades, that footprint is going to be somewhere else. The part of the Arctic receiving the most direct particle flux in the 2030s will not be the part that received it in the 1930s. This is a genuine, testable, unglamorous consequence of pole migration, and it is more interesting than any prophecy, because you can go and check it. Cosmic ray flux at high latitude is measured by neutron monitors on the ground. Auroral geometry is measured constantly by satellites and by ground-based imagers. Ionospheric conditions in the polar cap, which affect high-frequency radio propagation and transpolar aviation routes, are monitored operationally because airlines fly over the top of the world every single day and need to know when their communications and their radiation exposure are going to be affected. That last point deserves a sentence of its own. Transpolar flights, the routes that run from North America over the Arctic to Asia, are planned with space weather in mind, because at those latitudes the shielding is weakest, and crews and passengers take a measurably higher radiation dose than they would at lower latitude. Airlines reroute during major solar events for exactly that reason. As the pole and the auroral geometry shift, the map of where that exposure is worse shifts too, and the people who plan those routes will be the first to have to care. So the honest list of consequences from a wandering magnetic pole looks like this. Navigation models require more frequent updating, and one of them has already needed an unscheduled emergency release. Airport runway designations get renumbered. Magnetic declination corrections on every chart in the Northern Hemisphere change. Satellite operations in the South Atlantic get harder as the anomaly deepens and spreads. Auroral geometry reorganizes. Polar route radiation exposure maps shift, and the region of the Arctic receiving the most direct particle flux migrates from the Canadian side toward the Siberian side. Not one item on that list is an apocalypse. Every item on that list is real, documented, and being actively managed by somebody right now. And I want to be direct about something, because I think it is the most useful thing I can tell you in this entire video. The reason the honest list matters more than the dramatic one is that the honest list is checkable. Every single item on it generates public data that you can go and look at yourself. If the situation deteriorates in a way that matters, it will show up in those places first, in documents with dates and numbers on them, published by agencies whose job is to publish them. The dramatic version, by contrast, is unfalsifiable. It has no thresholds. It never specifies what observation would prove it wrong. And a claim that cannot be wrong cannot help you. Which brings us back to where we started, because there is one more thing that has to be dealt with before we finish. The pattern that everybody noticed in the middle of August of 2026 is not nothing. I've spent this entire video taking apart the explanations offered for it, and I owe you my own account of what it actually is. Part 15. The pattern properly assembled. There is a word for what is actually going on, and it comes from statistics rather than from prophecy. The word is envelope. An envelope is a set of background conditions that changes the probability of events without causing any individual one of them. It is the difference between a loaded die and a rigged game. A loaded die still produces random results. Every roll is genuinely unpredictable. But the distribution has shifted, so over many rolls you get more sixes than you should. A rigged game is different. A rigged game has somebody choosing the outcome. The August cluster is a loaded die, not a rigged game, and the loading is real. Here is the envelope Earth is currently operating inside, item by item. There is a strong El Niño running, which has loaded the Pacific with heat, and that warm water is why a cyclone could form fast enough and hold together well enough to put a hurricane over the Big Island for the first time in a century and a half. We are on the descending side of an energetic solar cycle, which by the weak statistical evidence we examined is very slightly associated with more volcanic activity, and which more concretely means the recurring coronal hole streams and geomagnetic activity that define that phase of a cycle. The magnetic field is in an asymmetric reorganization, thinning over the South Atlantic, thickening over Siberia, with the northern pole executing the largest deceleration ever measured. And the global earthquake catalogue is running front-loaded, with a magnitude 8.8 in 2025 dominating the energy budget and a run of magnitude 7 events since. Each of those raises probabilities. None of them causes a specific event, and crucially, they are not connected to each other. El Niño does not affect the core. The core does not affect the Pacific thermocline. The solar cycle does not decide where a subduction zone ruptures. They are 4 separate dice, all somewhat loaded, rolling at once, which means the honest answer to the question everyone has been asking is neither yes nor no. It is, the events are independent, the conditions are unusual, and the overlap is what an unusual set of conditions looks like from inside. That is a genuinely different claim from, it is all a coincidence, and I want to be clear that I'm not saying that. Coincidence implies nothing is going on. Something is going on. It is just not a hand on a lever. Let me use the eclipse to show you what pure coincidence actually looks like, so you can tell the difference. On the 12th of August, the moon's shadow crossed the Arctic Ocean, reached maximum over Iceland, and swept through Spain, and it happened to run along a stretch of the Gackel Ridge on the way. A lot of people found that meaningful, and an eclipse path is set by orbital mechanics that were established billions of years ago and can be calculated to the second for the next 1,000 years. The path of the 12th of August 2026 was fixed before any human being was alive to see it. Volcanic systems sit where plate tectonics put them. The only way for an Arctic crossing eclipse to avoid the Gackel Ridge would be for the Gackel Ridge to not cross the Arctic. That is not a pattern. That is two grids overlapping because both of them are drawn on the same sphere. Compare that to the Kamchatka case, which passed every test. Short interval, short distance, primed systems, a real mechanism, and researchers willing to state the connection on the record. That is the standard. The eclipse alignment does not clear a single one of those bars. The magnetic volcanic claim clears none of them either, and its supporting literature has the arrow reversed. The solar volcanic claim clears the statistical bar weakly and fails the mechanism bar entirely. 1 case out of 4. That is the actual score, and I would rather give you the actual score than a comfortable one in either direction. Now, 2 corrections before I let you go, because I promised them, and because they matter. The first is Toba. The magnitude 6.9 that struck Western Sumatra at 172.5 kilometres depth is only frightening if you believe the story that has been attached to Toba for the last 30 years, which is that the eruption roughly 74,000 years ago nearly ended our species, driving humanity down to a few thousand individuals and leaving a genetic bottleneck as evidence. That story has substantially collapsed. Multiple genetic analyses have looked for a bottleneck at that date and failed to find one. Archaeological sites in India, which are the most direct test available because they sit under the ash itself, show continuous human occupation above and below the Toba ash layer, with similar tools and similar behaviours on both sides of it. People were there before, they were there after, and they were doing the same things. Primate populations in the rainforest immediately surrounding Toba show no fossil evidence of bottlenecks either, and sediment cores from Lake Malawi in East Africa, which would have recorded a global volcanic winter with great sensitivity, show no major change in sediment composition or temperature attributable to the eruption. The genetic reduction that the original hypothesis was built to explain has other candidate explanations, including founder effects from migration. The current reading in the literature is that the Toba bottleneck is an oversimplification, and that early humans turned out to be considerably more resilient than the catastrophe model assumed. So Toba was an enormous eruption, and it was not the near extinction of humanity. And no monitoring agency has reported unrest there, and a deep earthquake nearby is not an eruption precursor. The second correction is the one I've been holding since the beginning, which is Yellowstone. It is quiet. No elevated alert level, no unusual swarm, no deformation signal being flagged by anyone. The largest and most famous volcanic system in North America is sitting the entire August pattern out. In an honest accounting of a claimed global activation, that absence is evidence, and it points away from the doom reading. I have told you that not because it is comfortable, but because a video that only presents the parts that fit is a video you should not trust on the parts that do not. And on preparedness, briefly, because it is where a lot of this conversation lands emotionally, and it deserves a straight answer rather than either mockery or amplification. Keeping some food, water, and a way to make power in your home is reasonable. It is recommended by essentially every emergency management agency on the planet, and it does not require a magnetic justification. It is good advice for a winter storm, a grid failure, an earthquake, or a bad week. If the magnetic field gave you a reason to finally do the sensible thing, fine. But do not let anyone tell you the field is why you need to, because the field is not why. So here is where all of this leaves us. Earth is not a finished object. That is the thing I keep coming back to, and it is the honest lesson of the last 2 hours. We inherited a picture of this planet as a stable platform with weather happening on top of it, and almost every part of that picture has turned out to be a snapshot mistaken for a portrait. The pole is not where it lives. It is where it happened to be when we invented the instrument to find it. The field is not fading uniformly. It is redistributing, thinning in one hemisphere and thickening in another, straightening at one end while bending at the other, running through a reorganization whose end state nobody can name. And 3,000 kilometres beneath the ground you are standing on, a machine of liquid iron that has been running for billions of years changed the way it was running sometime in the 1970s, and the only reason we know is that a dot on an Arctic map started moving faster. We have always believed we were watching the planet. What we have actually been doing is reading its dashboard, from the outside, with instruments we invented 5 minutes ago in geological terms, and being surprised every time the needle moves. And there is one thing about all of this that I cannot stop thinking about. Somewhere out on the sea ice at 85.76 degrees north, 139.3 degrees east, there is a spot where a dip needle should point straight down into the Earth. A model says so, satellites say so, nobody has been there to find out. The last person to physically stand on the magnetic North Pole and watch a needle drop did it in 2007, on ice that has long since melted or drifted away, and since then the pole has moved hundreds of kilometres, executed the largest deceleration ever measured, and set a course for the strangest volcanic ridge on this planet. So the question I'm left with is not whether the field is failing, because it is not. It is this. If somebody finally went out there and set up a dip circle at the coordinates the model predicts, and the needle did not point straight down, what exactly would we have learned about the machine underneath us that we do not currently know?